essentially, slip angle is the difference between the direction that you're facing and the direction that you're travelling. That angle there is slip angle. Very common in drifting vehicles to be that big drift angle that the car has got. That is a measurement of body slip angle, and that is normally taken at the centre of mass of the vehicle to give you one value, but that body slip angle at the centre is different to body slip angle measured at the front of the car or at the rear of the car. And that is due to the fact that the body, which is always facing one direction as a solid body, with the fact that the vehicle yaws around a turn, the front of the car with its steered wheels will go in a different direction to the rear of the car. Follow me. If you imagine that you were sitting on the front of the car when the car was turning, this is the direction you're facing, but with the front wheels on a turn angle, that's the direction that you're heading. That's quite a large angle. Let's go to the rear of the car. If you imagine sitting on the back of the car within the same manoeuvre, the body, of course, is facing the same direction as it was at the front. However, your sensation and your direction of travel at the back is actually slightly outward of the corner, not following the front of the car, determined and dictated by those front wheels. Completely different measure of body slip angle. Tyre slip angle has exactly the same basics as the body slip angle. It's the difference between the direction that the wheel is travelling and the direction that the wheel is facing. With most cars, the rear wheels are fixed, they're not steered, which means a body slip angle measurement at that point will also be the same as tyre slip angle. Different story with the front wheels. The same basic theory applies, that the tyre slip angle on a front wheel will be the difference between the direction it's facing and the direction that it travels. Because it is steered, the difference being when we measure it is we can again measure body slip angle at this point on the car, and then we simply subtract the measurement of the wheel angle to give us the tyre contact patch slip angle. So given that slip angle is the difference between the direction that you're facing and your direction of travel, how are we going to measure that on this car today? Well, we've fitted a VBOX 4 dynamics and an IMU 5 system running an inertial integration. The course over ground will be measured by the VBOX as the direction of travel of the vehicle, and then a yaw derived signal from the IMU will give us the body angle. What we can do within the VBOX is translate that course, that direction of travel measurement to 5 places on the car. Front left tyre, front right tyre, rear left, rear right, and then a centre of mass. In addition to that, because those front wheels are steered, we've tapped into the CAN bus in this car to pick up the steering angle. We know the rack ratio, so divisor on the steering angle of the rack ratio will give us the wheel angles. With those wheel angles, we subtract that from the body angles measured at that point, and we've got the front tyre slips as well. So we're now on the wet grip track. Nick's holding the centre line where there's reasonable grip, so we're maintaining under neutral steer, minimal tyre slip at the front and the back. The tyres are keeping us on the line we're on, but the body slip angles at the front will be very different. At the front of the car, the way the car is facing and the way the tyres are facing is quite large. So let's go into a low mu service and instigate some oversteer. Nick, if you could do that. And there we go. Large amount of oversteer. Nick has counter steered now. So at the tyres at the front, they're travelling pretty much in the direction and Nick has got them steered. So there's very low front tyre slip, but clearly with the rear wheels, the direction that they're facing and the direction that they're travelling is very large. And as I look at the data I've got in front of me live on the laptop, Nick is achieving about 25 to 30 degrees of rear tyre slip angle, whereas the front tyre is only getting about 3 degrees, a negative 3 degrees actually, because obviously he's steered in, so therefore the slip angle on that tyre is a different sign. That's great. Thanks, Nick. So Nick's going to induce some understeer for me now. coming in on a straight tangent line to the low grip surface and then turning on the steer angle. The momentum of the car is going to be in a straight line. The low traction of the surface will mean that the wheels won't immediately grip, so therefore a big steer angle, continuing drive line, is going to be understeer. And then once the tyres start to get some adhesion, I imagine it will move into oversteer. So let's see what happens next. Here he goes into the low surface. Turns on with the steering wheel. Yes, loads of understeer, loads and loads of understeer, and now they're starting to grip, and they're rolling around now, and there we go, transitioning into 35 degrees of oversteer. Thank you, Nick, that was perfect. So we've come back in off of the track now to look at some of the data we've captured. I've cut down a bit of the file to a particular bit that I was interested in. As well as in the car, I felt it, I could see it, but I wanted to just highlight that to you, Nick. It was when we were driving down the track behind us there, the dry track onto the wet grip surface. So you're going in on a straight line, we then meet the low mu surface, you turn a whole load of steering angle in, and the car understeers. It actually understeered for quite a while, even though the car was rotating around the circle, and then a whole load of oversteer came on. So we've got the data in front of us, and to start off with, you can see us driving in the straight line, the body of the car's in the straight line, no body angle to speak of, no tyre slip angles, and you can see that in the data. We've got 0.2 degrees, 0.1 is very, very low amounts. And then just as we enter onto the low mu surface, a whole ton of steering angle, and consequently, absolutely, yeah, and consequently, we've got front tyre slips of 20 degrees. And it maintains that 20 degrees. There's enough grip on the tyres, you see the rears have got a little bit of grip there, that the car does rotate and turn, and I can see that. But then, after a bit of that, it changes, which I now realise in the data, and I can see it. You gave the accelerator a blip here, the RPM goes up, consequently you force the rears to break traction.
That's it. So at that point, if you remember rightly, it was the front nose was still starting to slide up towards the exit.
It was.
So it was one of them to trim it back into the angle, flip of the throttle,
you were controlling
encourage it back over to oversteer, and obviously,
and then after that, if I can get, see if you agree, is I can see that you did that with the throttle. That caused the rears to break, the back end came out. Yeah. And at that point, we've got a massive transition in that measurement. The rears now become a large amount of tyre slip angle. You've got 31 degrees, 33 on the back. The fronts have changed sign. Allied into your steering angle, rather than the tyres understeering that way, you've now turned in and the tyres are now slipping the other way, so they've got an opposite sign. But the other bit that's there is I can see that it's varying a bit. So what are you doing there?
So,
yeah.
You see it now?
Yeah.
That's the fine tuning. So as the car obviously snapped out, it's a sudden input to try and catch it initially, and then it was just fine tuning it and
there you go.
Control from there.
And now you say that, I can see that because we've got an increase. You come off the steering angle a little bit, and that steadied it, but then it starts to travel out to an even greater amount, 38 degrees, 37 degrees of rear slip angle, but the steering angle's gone further. Yeah. So that's what you're just saying, isn't it? That's you.
Exactly that. And if you look at the throttle as well, it's basically stayed off completely the whole time. So that's just trying to find where the car's angled at.
And then just the fraction after that, you've turned in more steering angle, you've caught the rear end, and then you're balancing between the throttle and the steering angle there, which is pretty cool. You've turned in, you've caught it, but then the RPM goes up and you've got a little dab just to maintain that very steady amount of 30 degrees of rear tyre slip. You then, as we can see, completely lift off the throttle. The engine RPM comes down, which is then what's allowing the rears to gain traction on that low mu surface again, which causes with the measured tyre slip goes down, the body slips go down, the car straightens up, back onto the steering line that you're asking for, because at that point you brought your steering back in, and then as you transition off the track, the body of the car's back in a completely longitudinal line for the path we're on. Slip angles back down to 0.1 degree, 0.2 degrees.
Brilliant.
Yeah, it's subjective and objective, isn't it? We were out there doing it, you knew what you were doing, we captured the data, and it's great to be able to see the data working so well and accurately, and with your accurate driving as well, we were able to create and simulate those understeer and oversteer situations.